Welcome to lesson 4.2, apply congruence and triangles. So in other words, we are looking at the idea of congruence and congruent figures, and we will be applying that mainly to triangles and the idea of being able to state if triangles are congruent or not. So in congruent figures mean that all parts of one figure are congruent to the corresponding parts of the other figure. So it means it will end up being the same size, same shape. It may be flipped or turned, but when we match it up with the corresponding parts, it is the same size, same shape, same angle measurements, side measurements, etc. Then when we are writing a congruence statement for two polygons, you always list the corresponding vertices in the same order. So if on one triangle A matches up with F on the other triangle, you would have to start with A and F in corresponding parts. So we're going to look at that in example 1. Example 1 wants us to write congruence statement of the triangles. Identify all the parts, or identify all pairs of congruent corresponding parts. So let's look at A first, not worry about B yet. In A, we have triangle DEG, and then we also have triangle GEF. Now, what do we know by looking at the image? We know angle D and F are right angles, and they're also congruent to each other. So angle D is congruent to angle F. They both have the right angle symbol. This angle has a single arc, and so does this one, meaning those two are congruent. So angle GED would be congruent to angle EGF. Then I know DE has this double hash along with GF. So DE and GF are congruent to each other. And then EF has the single hash along with DG. So EF is congruent to GD. And then we also know that GE or EG is always congruent to itself. So we know all these different pieces. So now what can we do with that info? Well, I know D matches up with F. So wherever I put D for one, it has to match up with F when I name the other. Wherever I put E for the one that's DEG, it has to match up with G on the other. So if I started triangle EDG by naming it triangle E, then D, then G, for my other triangle, I need to match up the vertices that are congruent. So E on this first triangle is congruent to G on the second one. So the second one starts with G. Then D came second. D corresponded with F. So F is second on this one. And then G on the first one corresponds with E on the second. So it'd go G and E. If I would name this DGE, then this would have to go FEG. So you have to match up the corresponding vertices or letters. In B, let's look at what we know. Well, we have two triangles, and I know all the angles, angle N, P, and M, have a single arc. Angle T, R, and Q have a single arc. So I know angle N, P, and M are all congruent. T, R, and Q are all congruent, and they're all congruent to each other. But then the sides on triangle NMP only have a single hash. So I know NP is congruent to MP, which is congruent to NM. Same with TRQ, it has double hashes. So TQ is congruent to QR, which is congruent to TR. But I do not know that the sides on this triangle are congruent to the sides on this triangle. I know all the angles are equiangular, but I don't know if the sides are the same length. So based on that, there is no congruence that I can write between the two triangles. Just because the angles are equal doesn't mean that the sides are also equal length. Now let's look at the idea of congruence to find missing pieces. So they tell us triangle HJK is congruent to TRS. So if I look at the way that they name this, H came first and T came first. So I know H equals T, or those two match up as corresponding. J in the middle and R, so R and J go together. And K is congruent to S, or K equals S. So now find the values of A and B. A is part of angle T here. B is part of angle K. So let's start with figuring out A. So angle T, 6A minus 3, T matches up with H. So angle T has to equal 51 degrees. So 6A minus 3 equals 51. Add the 3, divide by 6, and A equals 9. Then I could figure out what angle K or S are based on that information. If I know this is 51 degrees and R is 83, that tells me J is also 83. So I can do 180 minus the 51 and 83 to find out what this angle equals. So 180 minus the 51 and 83 gives me 46 degrees. So I know angle K and S both equal 46 degrees individually. So then I can just take this info, 7b minus 10, and set it equal to 46 degrees. Add the 10, divide by 7, and b would equal 8. Example 3, same concept. We're told triangle ABC is congruent to DEF. Find the values of x and y. So I know A corresponds with D, B with E, C with F. So then if I look at this, if E is 42 here, I know B is also 42. So then in this triangle, I have 42, 87, and 3y. So 180 minus the 87 and 42 would give me the measure of angles C and F, which that would have to equal 51 degrees. So now I know to figure out y, 3 times y, 3y here, equals 51 degrees. So y would equal 17. And then to figure out x, I know D matches up with A. So D, 5x plus 12, equals A of 87. So 87 equals 5x plus, not 12, 2, sorry. Subtract the 2 from each side. Divide by 5, and x is also 17. So in this case, both x and y are 17. Then we get to our new theorem for this lesson, theorem 4.3, which is the third angle theorem, which states if two angles of one triangle are congruent to two angles of another, then the third angles are also congruent. So if we look at my two triangles here, if angle A is congruent to angle D and angle B is congruent to E, then we know angle C is congruent to angle F. And then we're looking at our proof here. So to complete the proof, again, they gave us statements on the left, conclusions or reasons on the right, and we're filling in the blanks. So we were given that angle ABD is congruent to CDB, angle ADB is congruent to CBD, and then segment AD is congruent to BC, AB is congruent to DC. They want us to prove triangle ABD is congruent to CDB. So all of our congruencies are marked in the image. So then, angles, all this info here on the sides being congruent was all part of the given. After that, they said angle BD is congruent to BD. So BD, and B is this upper corner here. So I forgot to label that there. It goes A, B is the upper right, CD. So DB congruent to itself, anything equal or congruent to itself is the reflexive property. So for 2 our reasons, the reflexive property of congruence. Then they went on to use the third angle theorem. Well, we already knew that angle D down here from BDA would equal up here angle CBD, and then BDC down here equals ABD up here. So what's missing is angle A and angle C. So in our third angle theorem, we could say angle A is congruent to angle C. Then our final statement, triangle ABD is congruent to triangle CDB, is the definition of congruent triangles. So the definition of congruent figures, in this case, more specific definition of congruent triangles. All the corresponding parts are equal. And then we get to our last theorem for today. Theorem 4.4 is the properties of congruent triangles. So we have 3 here. The reflexive property, which says for any triangle ABC, triangle ABC is congruent to itself, ABC. Then we have the symmetric property of congruent triangles. So we're looking at these 3 triangles as our example. It says if triangle ABC is congruent to triangle DEF, then we can flip that order and say triangle DEF is congruent to ABC. And then our transitive property says if we knew triangle ABC was congruent to triangle DEF and triangle DEF is congruent to JKL, then we could say triangle ABC is congruent to triangle JKL.